Hello, we're going to try a problem from College Physics 2, which means that this actually has something to do with electric charges, electricity and magnetism. And just a little bit of notes, this will be on chapter 15 on electric forces and electric charges, and specifically electrostatic equilibrium, which harkens back to one of Newton's laws of motion. So without further delay, let's carry on. And you can see here, we're already given a diagram, okay, where the charges on B and C are one coulomb. That's actually pretty darn big, but that's what we're given. And they're equal. And the charges of A and B are equal but unknown. We're trying to figure out charges here. Okay? And we're trying to figure out what should the charge on A be so that all the forces on charge B should equal to 0. Okay, hope I didn't confuse anyone there. So the charge on B equals the charge on C, which are both one column, and is actually positive. Okay, the charge on A is equal to charge on D, and that should be something negative. Okay, and also we're given that this is a square, so I'm going to call this side S, 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 S. And so if we were to find the diagonal, then that would actually, if you remember your Pythagorean theorem, then this should be square root of 2 over S. And how did we get that? Just simply using good old Pythagorean theorem. So we'll need that a little bit because they're arranged in a square formation. Okay, so that essentially is also one of our given. Okay, and our goal is to find what is QA such that all the forces on charge B equal to 0. Okay? And the formulas that we'll need are a combination of something from Physics 1 and Physics 2, this chapter in particular. We'll need from this chapter Coulomb's law. Take note you're not including the signs. You have to take into account that when you're doing the diagram. And we'll need the law or the equilibrium rule. All the forces equal to 0, and I like to add in addendum where all the forces on the X, since this is two-dimensional, equal 0, and all the forces on the Y should equal to 0 as well. Okay? So take note, Newton's first law, and particularly since we're talking about charges, this is electrostatic equilibrium. And what that means, there is no motion of the charges. They're all staying put. So no V, acceleration is 0, and so the velocity is 0 as well. Okay, that's pretty much it. Okay? So let's go to this diagram. Let me erase everything here. Take note, you will need Pythagorean theorem to solve that. I'm going to use black. So we know the charges here are positive, positive, and that would, by consequence, these charges on A and D, since they're equal, should be okay. And so we're taking everything into perspective with charge B. Okay, so between these two forces, it should be attractive. So from the perspective of B, it feels a pull there in actually the negative X direction. And between the perspective of these two forces, it feels a pull downwards from our frame of reference, and actually in the negative y direction. How about these two guys at the diagonal of the square root of 2? Well, these are obviously the same, so that means the same repel, so it will feel an equal and opposite, an opposite to the diagonal of repelling force. And that angle should be at the same angle that the diagonal is at, which should be 45. So let's write that down. So there should be a force here. It's negative, and I like to write down force of B on A. Okay, and this is also attractive, but it's pointing in the negative direction, the force of B by D. And then here, last, I'm making that a little bit longer for a certain reason, force of B caused the repelling force by charge C. And that's actually positive, if you notice, it's in quadrant 1. And this force here is going to have an X, I'll just put a solid, and a Y component. This angle should be 45. Should be the same angle here, if that is 90. Okay? And so this would be FCBX, which should actually be, take a little shortcut, should be cosine, since it's adjacent, and this should be FCBY, and it's opposite the angle, so it should be sine. And these sine and cosine components, or this x and y components of this, should actually be equal because of the angle of 45. And that's pretty much everything that we need to solve this problem. So let's try it out. Okay, so I am going to start with sum of all the forces equal to 0. And not just that, but either x and y. And as a matter of fact, you can either choose one or the other to solve this, and you would still get the same answer. Okay, so I'm going to choose the first one. Whoop. And so the sum of all the forces on x on B are equal to 0. And as you can see here, there's only two. It's that x component, that cosine 45, and FAB, which is actually pointing in the negative direction. Okay? So I'm going to start with the negative FAB. I'm actually not going to write the signs. It's going to take into consideration already. And plus, since it's FCB, cosine of 45. And take note, a lot of the take notes, we're going to take that as the equation. Even though we started here, I can choose that part. Okay? So I'm going to take this and I'm going to move that to the other side because I don't like negatives. Let's be positive. So I get FAB equals FCB cosine 45. Okay, so now we're going to plug in Coulomb's law. And also for all you unit circle fans, you should know that this should just be square root of 2 over 2. Look it up, unit circle. So applying Coulomb's law to this, we're going to get KE, QA, is that what we're looking for? And the unit for, the value for B is actually 1 coulomb over S squared, because the side here is S. Oops, yeah. And then I have KE here as well, but the charges of C and B are actually 1 coulomb apart, a piece, not apart. But the distance now is square root of 2S. So it's actually square root of 2S squared times that square root of 2 over 2. Now notice a lot of things are going to cancel out here. I have KE on both sides. I have 1 coulomb, so actually a unit of coulomb is going to cancel out. this square root of 2s squared is going to become 2s squared, and so that's going to cancel out. Okay? And as a matter of fact, one of these, no, that's fine. I think we're good. As you look and see what was left behind, you'll notice, so the column, I'm going to put this at the end. It has square root of 2 times 2 times another 2, and then there's a column at the end. Okay, so basically that's just square root of 2 divided by 4, and you notice that the magnitude is actually it rounds up to be 0.35 in two significant figures. The magnitude of the charge on A. So what sign was this? If you go back, our sign is Virgo. No, it's not. It's negative. Okay, so in this case, oops. And there you go. It had to be negative in order for all the forces on B equal 0. Now, if we had started with this, we would get a similar set of equation, but still end up with that. How neat is that? Okay, try it out. Hope it all works out. Enjoy.